So good morning. We'll try to solve this problem. The question asked is find V naught output voltage. So we have a number of stages of transistors and we'll name them as this is Q1 transistor, this is Q2, this is Q3 and this is Q4 and finally we have fifth transistor available. Okay. And if you check this Q1 transistor and then Q2 and this Q4 and Q5, these are all NPN transistors we know, and this Q3 alone is the PNP transistor. Okay, so that's why here if you see in the given specification, the mod of VBE is given as 0.7 volts. Okay, so for NPN transistor, we'll be taking this as VBE equal to 0.7. So when it is PNP, we are going to consider it as VBE that is equal to 0.7. Otherwise, you can also write this as VBE is equal to minus 0.7 volts for the case of this PNP transistor. That's why it's given as modulus. Okay, and one more thing is given here as the hint is beta is very large. So when it is given as beta as very large, then we should know that IB is 0. Okay, so whenever beta is very large, IB need not be considered as 0, so that we know that IE becomes IB, IC. Okay, because we know the current equation usually it is IE equal to IC plus IB, and that IB becomes 0, so that we are getting this, right? So now we can move on to this diagram and we try to solve this. So since this is 10 volts supply is given here in VCC 10 volts, okay, so VCC we have here as 10 volts, right? So how much it would be appearing here? We can use the voltage divider rule, VDR, or by looking at this we can immediately say that as these two resistances are equal, we can say that 5 volt will be appearing at this point. Okay, otherwise we can also go for this voltage divider rule, in that we can say that the supply given multiplied by the resistance of this particular branch divided by the total resistance 5 plus this 5. Okay, so how 10 into 5 divided by 10, so here we are going to get this as 5 volts. That's why I told you that this 5 volts will be appearing here plus 5 volts. Okay, after that if you see here, this is VBE, so VBE is 0.7 volt according to the given condition, so that this 0.7 volt will be dropped here. So what is remaining available here is 4.3 volt will be available. So VE, if you see this VE is equal to 4.3 volts and the resistance there available is RE, so that is equal to 4.3 kilo ohms. So IE that is flowing through that, okay, that would be equal to V by R, so VE by RE, so we will be getting this as 1 milliamps, is that. Okay, 4.3 divided by 4.3 kilo ohms, so it is 1 milliamps. Since we know that IE and IC are equal according to this very large condition of beta, okay, know that this IE is equal to IC, that's why the IC current that is flowing in this direction, we know that IC current will be flowing from this direction, it is flowing. This is our IC. So because of this IC current, which is 1 milliamps, we will be having a voltage drop of 2 into, how much will be dropped across this? 2 into 1 milliamps. Okay, this is here we have the 2K. So 2 in K into 1 milliamps drop will be there at this point. So that if you check here, what is the voltage at this point? VC, we can take it as VC1. And this can be considered as VE1 or E1 because that corresponds to the first transistor. Okay, so VC1 will be, here we know the supply voltage 10 volts will be appearing. After that this 2 volts drop will be there because of this IC current. So VC1 is equal to 10 minus 2 volts. So 8 volts will be appearing. Okay. So at this point VC1 we get 8 volts. Here we get 8 volts. So after that we have here this VBE is coming again. VBE, here you can take it as VBE1, it can be considered as VBE2. So VBE2 is actually equal to how much again? If you check, that is also 0.7 volts. So that at this point if you measure, it is nothing but VE2. Okay. So that VE2 will be equal to VC1 minus this VBE2, right? So that it is 7.3, because this is 8 volt, this is minus 0.7 volt. So we will be getting this as 7.3. So this VE2 is 7.3. So that 7.3 will be appearing at this point. But here we should know that we have the PNP transistor. Understand that we have the PNP transistor here. So we cannot simply put here the, okay, here only we have this VP or VEB will be appearing. VEB will be appearing because we know that this is your base and this is your emitter. Okay. So this VBE will be appearing at this point. Okay. So that is equal to how much? VBE is equal to 0.7. We know that. This is 0.7, but anyhow it is VEB. So this is plus and this is minus, right? So when you go from this point, to this point, okay, from here to here, if you measure what is happening, this is our V emitter. Again, this is emitter of this transistor number Q3. Okay, so this is VE3. So if you measure this VE3, that VE3 will be equal to this 7.3 plus this is voltage rise. Okay, so it is 0.7 volts. So you will be getting it as 8 volts. So this VE3 will be having 8 volts. Okay, that 8 volts will be appearing here. So you get 8 volts. After that, here it is again NPN transistor. So 0.7 volts for this VBE. So this is a voltage drop. So if you measure this VE4 at this point, VE4 is equal to that 8 minus 0.7. So again you will be getting 7.3. So the 7.3 volts will be appearing at this point. After that also you will be having this voltage drop across this, that is 0.7 volt. Okay, so at this point it is VE5. Okay, we can measure VE5. So VE5 is equal to this 7. How much is available here at VE4? 7.3. Okay. So that 7.3 minus this voltage drop of 0.7 volts. So you'll be getting this as 6.6 volt. So VE5 is 6.65. But we have to find out V naught. V naught is nothing but this VC5. Understand? This is VC5. So that we need to find out the current which is flowing through that resistance. Then only we can calculate this VC5. Okay. So now we know this VE5 we have found out at 6.6 volts, and there we have the RE resistance. Okay, this is the fifth. Okay, so that is equal to 6 kilo ohm we are having. So I can find out the current IE5 that is flowing through that one, that is equal to 6.6 divided by the 6. Okay, I don't put this kilo ohm because any of this emitter current will be coming in milliamps. Okay, we'll be obtaining it in milliamps, so they will cancel. So what this value is 1.1 milliamps. Okay, so this is IE5. So once you know this IE5, this is nothing but your IC5 also, because we know that no base current will be flowing. So through this, we'll be having this IC5 is flowing. This IC is flowing, okay, that is equal to 1.1 milliamps. So because of that, you will be having a voltage drop across this resistor. So across this resistor, you will be having a voltage drop of 1.1 volt. Okay, that is a voltage drop across this 1 kilo ohm resistance, because the resistance is there. The current flowing through that one is 1.1 milliamps. So the voltage drop is 1.1. So this voltage is 10 ohms. After that you have a voltage drop. So after that you have this VC5. So what is your VC5? If you check, VC5 is equal to this 10 ohms minus this 1.1 volt. Okay. So it is 8.9 volt. So this VC5 is nothing but our V0. So the answer is V0 is equal to 8.9. This is our answer. Okay. Thank you.